is Srividya, pursuing BTech second year from CLC department. I am doing a video from the subject about database management system, and today my topic is the topic is given by a question. What is the question means? Suppose a transaction T1 starts, performs several operations and encounters an error before completing. Describes the different states T1 transition through during this process and explain how the system ensures that T1 does not leave the database in an inconsistent state. From this question I selected I got the title. I selected a title like transaction cycle and error handling. Before going to transaction lifecycle and error handling, and the subtitle is ensuring database consistency to transaction management. Before going to tell about different types of transition, let's know about what is a transaction. Introduction to transaction management. A transaction is a unit of work performed within a database that is treated as a single logical unit. And here our goal is ensuring data consistency, atomicity and isolation. And what is the key properties of a transaction management is commonly called as ACID property. The abbreviation of ACID in the database management system is A refers to atomicity, C refers to consistency, I refers to isolation, and D refers to durability. Let's go to the different types of transaction state overview. There are 5 types of transaction states. One is active state, and second one is partially committed, and third one is failed state, aborted state, and committed state. Firstly, we learn about what is active state, what are the transaction of T1 get inconsistency in different states and consistency ensuring data integrity. Going to the active state, temporary storage mechanism. The active state will go under the ensuring consistency about the temporary storage mechanism. The system utilizes temporary storage to hold modifications made by a transaction T1. This approach prevents immediate changes from impacting the main database, ensuring data integrity. Once the T1 is completed successfully, changes can be committed to the database, maintaining a stable environment. Here, the given image is talk about the temporary how the data will be going to store in the temporary storage mechanism, and what is the use of temporary storage mechanism. So, going to second state, partially committed state. Understanding the T1 state transition. Here, the T1 is a critical state in the system that dictates the flow of operation. When no issues are detected, T1 will progress to the next case as intended. If an error is identified, T1 will remain in its current state to ensure system stability. Here, the state transition diagram. That are the steps which the transaction is partially committed, said to be partially committed. If the transaction, for example, if the transaction of T1 is transferred a amount of 100, if the transaction is failed, we can roll back this going to partially committed state. And the third one is failed state. When the fluctuation happen, the transfer of money will get error. By this for this situation, we roll back the operation. Understanding the rollback operation. A rollback operation is a critical process in database management system that undoes changes made during a transaction. When a transaction such as T1 fails or encounters an error, the system automatically reverts to the previous stable state. This ensures data integrity, consistency, preventing the partial update from corrupting the database. This failed state This parent state refers to in the database management system when the amount of 100 is transferred to account A to account B. The amount as right as 100 in account A, but amount does not write in account B, so the fluctuation happen and the system get error. In this situation, we roll back the operation of rollback system is performed. Second, going to fourth, aborted state, ensuring database consistency post rollback. The aborted state is either the transaction of the either the T1 of transaction is completely aborted or never or coming to beginning state. After a rollback, the database reverts to a state prior to the transaction, effectively negating any changes made by T1. This process ensures that all the data integrity constraints are maintained, preventing and potential inconsistency. Consequently, the system guarantees the database remains in a consistent state as if T1 never have been executed. If the transaction of the money is fully or either aborted or fully executed, should not be in error, operation, or fluctuation. This leads to inconsistency that refers to the what is the aborted state. Going to committed state. Understanding the transaction commit states. In transaction processing, a committed state indicates that a transaction has been successfully completed and its changes are permanent. If no errors are encountered during the transaction, T1 will successfully transition to the committed state. In the transaction processing, a committed state indicates that the transaction has been successfully completed and its changes are permanent. Here, the point is referring to a committed state. The transaction is successfully completed. When we, for example, if a transaction made from account A to account B, we get the message of the amount is transferred from this account to this account. That is called by the successfully completed and change. If no errors are encountered during the transaction, T1 would successfully transition to the committed state. While transferring the money, there is no errors are encountered during the process of transferring the money. The T1 would successfully transition. Means this transition is called as committed state. Reflecting successful execution means the amount is safely transferred to the another account without any encountered errors and fluctuations. Achieving the committed state ensures data integrity and consistency within the database, make it crucial for the reliable database management. Means the committed state ensures that data integrity. Means the committed state is telling about the data integrity and consistency. This leads to data integrity and consistency within the database. Means this does not lead to inconsistency and no fluctuations happen during the transformation. And my conclusion is, from this question and topic, I have learned about the database transaction follow defined states to maintain consistency. Atomicity ensures transactions either complete fully or rollback. Rollback mechanism protects the database from errors. I concluded that the first point refers to the database transactions follow a defined state to maintain consistency. Due to inconsistency of transfer management transaction, the database is following some steps to maintain the consistency data. Atomicity. The atomicity defines that is undivisible, so that the transaction should not be divided. It should be like a unit that should not be divided. Ensures transaction that that completely, fully, or rolled back. Means the transaction should be completely executed, or neither should be uh, rolled back. The rollback mechanism protects the database from errors. Rollback means this mechanisms helps the database to to protect from the data inconsistency. From this topic, I have learned this about what the transaction management and the states of transitions, and how the transactions are made from one account to another account, and what are the states and what are the advantages and limitations. Thank you for giving this golden opportunity, sir, to explain this question. Thank you.